Okay, we will continue one more video. Relation between the equation for the equilibrium. Relation between relation between the equation for equilibrium and equilibrium constant. Relation between equation for the equilibrium and as well as equilibrium constant. What is the relation between this one, sir? If it may be noted that the k is changed. The k is changes if the coefficients of various species in the equilibrium are representing equilibrium. If you take one reaction, the coefficient of the reaction is changes, then equilibrium constant also changes. For example, you can observe here is this is manufacture of hydrogen iodide. When hydrogen combines with iodine to form hydrogen iodide, then equilibrium constant K1 is equal to concentration of Hi power 2 by concentration of H2 into concentration of I2. This is equation 1. If you take one more equation, now if the coefficients, stoichiometric coefficients of the reactants are changes, now what happens? Half mole of hydrogen combines with half mole of iodine to form 1 mole of hydrogen iodide. You can observe here K2, concentration of Hi by concentration of H2 power 1 by 2, concentration of I2 power 1 by 2. Now squaring on both sides, SOBS means squaring on both sides. What happened here? K2 square is equal to concentration of Hi whole square by K concentration of H2 power 1 by 2 whole square. These two are cancelled. Concentration of I2 power 1 by 2, these two are gets cancelled. K2 square is equal to concentration of Hi whole square by concentration of H2 into concentration of I2. This is equation 1. You can observe these two. K1 is equal to K2 square only. Okay, we can conclude that here, okay, this reaction, the equilibrium constant value is 49. In case here, square is their equation 2. Now I want K1 here, K2, okay, root K1. Okay, root 49 means that is equal to, K2 is equal to 7 only. Okay, it is also one of the relationship. It may be noted that the value of K changes if the coefficient of various species in the equation representing equilibrium are multiplied by some number. And one more is there, that is if K is equilibrium constant particular equation, then the equilibrium constant is multiplied by first equation. You can observe now I am taking one more equation here. That is okay, one more condition. Simply here, okay, first condition K1 is equal to K2 square, one equation, one relation. The second one is to take nitrogen combines with oxygen to form NO. K1 is equal to concentration of NO whole square by concentration of N2 into concentration of O2. If you take second equation, that is 2NO combines with oxygen to form 2NO2. Okay, in this reaction, the equilibrium constant, that is K2 concentration of NO2 whole square by concentration of NO whole square into concentration of O2. If you take equation 3, that is N2 plus half 2O2 gives rise to NO2. Here K3 is equal to concentration of NO2 whole square by concentration of N2 into concentration of O2 whole square. Now I am multiplying equation 1 and 2. Now what happens, sir? This one and this one, K1 into K2. Multiply these two terms. Concentration of NO whole square by concentration of N2 into concentration of O2 into this term. Concentration of NO2 whole square by concentration of NO whole square. Sorry, here now I am writing here. Concentration of NO whole square by concentration of N2 into concentration of O2, and equation 2, these two are multiplying. Concentration of NO2 whole square by concentration of NO whole square into concentration of O2. Concentration of NO whole square gets cancelled. Then the resultant equation, concentration of NO2 whole square by concentration of N2 into concentration of O2 into O2 square. This is K1 K2. This equation is K3 value. Therefore K1 into K2 is equal to K3. It is also one of the relation. We can find out that here, when addition of two equilibrium leads to another equilibrium, the product of their equilibrium constant gives the equilibrium constant of the resultant equilibrium. This is information about some relations between the equation for equilibrium and as well as equilibrium constant. Thank you.